Okay, we have another question here. It's a nice one. Let us go through it and see what happens. They're telling us that A, B, and C are 3 points in a straight line. A car passes through A with the speed of this and travels from A to B with the constant acceleration of this. From B to C, a car has a constant retardation of this. Whenever they talk about retardation, think about a negative acceleration and comes to rest at C. If the road distance from A to C is 475, find the speed of the car to B and the distance of B from A. Okay, so we start the sketch. So doing this sketch, now you see that the sketch is going to be very easy. We do our sketch like this. Now, they're telling us that the car passes through A. We are showing that this is our A, so it's passing through it with it. Starting velocity, this velocity is 5. That's why I'm having 5. So at for its use in a certain time, we don't know. By the time I'm assuming now from here up to here is capital T. Then they're not giving us this velocity. So then we call this velocity B. So now they're telling us that after that, now from B to C, a car has a constant retardation. Retardation means it's going to slope downwards, decrease, accelerating negatively. Retardation of and comes first to C. Coming first means the velocity is going to be 0. That's why we began up to this side, because rest velocity is 0. That's why we have to reach this, because from it's 0. Now we are assuming that now from B to C here, it's using T, small t, as the time to return from B to C. So from there, what happens? They're telling us that from here it's accelerating at meters per second, then from here it's returning at 3.5 meters per second. So now they're asking us to find the speed of the car at B. So they want us the speed of this car at this point B. That's why I'm calling this B. Okay. Now, first of all, to get I need, you see that I need the, you know that that's also that the total distance. So the whole area all over here is 475. So I need to know what this VB is, because it's going to act as, when I get the area of this, it's going to act as my longest side, and it's going to act as the height for this triangle. So what happens there? My VB, now VB here, this now is going to be the final. From A to B, now VB is going to be the final. That's why from here, my final velocity is VB, then the initial is 5, then acceleration is 2, then the time from here up to here, I'm calling it capital T. I call this note 1. Now, note from B to C, V is our initial velocity. VB is our initial velocity. Let me put that. Now, if we are going now from B to C, now this VB acts as the initial velocity for this journey from B to C. That's why where I have now my initial, but now the final velocity, because it's coming first, the final velocity is going to be 0. That's why when I reach here, the final velocity is 0, while the initial velocity is this in terms of B to C. That's why I have VB. Now that acceleration, because it's retarding, that's why I'm having the negative acceleration here. So my is going to be now negative 3.5. Now my time I'm using for this retardation is T. That's why I'm having small t. So that my VB is equal to this, because when I take this side, this one is going to be positive, this one remains positive also. Now, note that equation 1, this VB is equal to this VB. So when you pay this 2, you get that. Now, what else are you going to use? Now, so that I have this unknown, and then this unknown. I have 3 unknowns. What that calls for how many equations? It calls for more than 2 equations. So you can use 3 or 4, but I need 3 only because I have 3 unknowns so far. Now, you know that when I get this distance and this distance, I'll get 475 from the equation. I think it's the distance from A to C is 475. So meaning we get this distance S1. I think it's like the shape here we have is a trapezium. How do you get the area of the trapezium? The area of that trapezium is going to be that distance S1. So area of the trapezium is given by a half H, A plus B. Our A is the longest side, our A is the shortest side. So from here up here is 5. Then from here up here the longest side is BB. Then our height is our height is going to be our height. That's why I'm having here t. Then S2 is S2. We have a triangle, so it's going to be a half times base times height. Our base is t. Our height is VB. From here up to here is VB. So that's what I have. When I add them, I get the total distance, which is this. So now I substitute in this for S1 for S2 equal to that. Now I'm going to now here, because I have now, I'm going to make, I want only one unknown. So what does it mean? So I'm going to remove this, I'm going to remove this, and also remove this, but we are not starting with this. Now I want to make with only capital T. First of all, I know that VB is in terms of capital T is here. So when I put it here, the whole of this, I think you can see, that's my VB. Then also here I have this VB. Now I'm putting in terms of capital T, so that I have one unknown. Now I'm seeing this small t. Now can I express small t in terms of capital T? Yes, from this equation here. So it's that from here, if I want this, I divide this side and I get this. Now from here, I substitute this. This is a half. When I substitute now this here, that's what I get. Now 5 plus 5, I get 10 times this t. I get this t. Then this 2t times this t. That's when I get this square. So 2 times 3.5, that's when I get 7. When we multiply this and this, we get that thing up. Simplifying here, we come to this equation, divide 4 by 11. Two numbers, I multiply, I get 300, and I add, I get the positive 5, 20, and negative 15, and so our time is there. So how do we get VB? Our VB, we have T, capital T. So use this one. And substitute capital T as 15 times 230 plus 5 plus 5. Now the distance of B from A, we want now this distance here. I want this distance, which is S1. So now this S1, that's why I have this. I have this. So substituting, this is 15. BB is 35, and that will be the answer we shall get. So the distance of B from A is 300 meters, and that's how we go about that question there. So unless you have a question, you can leave it in the comment section. That's it. Let us see more examples.